Hi, it's Gadget UK here again, back with the A2000-A from Conrad. So in this video we're just going to finish this off. We got this working in the previous part there. I'm going to fit a brand new connector for the video slot over there because the one that's on there is a bit warped. I will be able to reuse that one at some point, but the pins are a bit bent on it, so I figured a new one of those. I've asked Conrad if he wants me to fit 2 more of these here, so I'm going to do that, which will extend the ISA slots here to 16 bits. But I'm going to start by removing the CPU socket here. We'll get a new turn pin socket on because the pins up this side of shade, they're just a bit dull, that's all, and I think it would benefit from having a brand new socket on. But we're also going to swap out all of the caps. They're primarily 47 microfarads, there's maybe a couple of 22, certainly for the audio section up there. We'll do that as well. So giving it the June test, I did have to rewrite my June disk actually. I think Cathar's A2000 corrupted that disk. I must have just never noticed. I left that demo going, but yeah, it wouldn't work. Anyway, the other thing I had to do is move this jumper over here, which I think is so there's a DF1 connected, because I noticed that when it did boot to Workbench Desktop, it was coming up DF1 question mark question mark question mark. If you've got a dual drive system, you'll need to have that jumper set. The one down here is for the tick, so again, if you're using a proper power supply, you want to change that back over to use the power supply tick perhaps, but you could leave it as it is and it will work. Live 2 RAM board works fine in here, as does the AT card, so you can get IDE and RAM easily. I still don't understand what the issue was when we cleaned up around these slots earlier, and then it just wouldn't boot for ages and ages and ages, so I was just getting weird things with it. Best way to do it is to lift it a little bit and then get into the gap, hang on if you can, like that, and then just leave slightly, that's it, and then you can just lift it off like that without hopefully damaging the board or the connector. Yeah, so I'm just going to take an opportunity now and clean up, so I'll start on the underside I think. Anyway, IPA and cotton buds. These are 4 layers, these boards, apparently. Yeah, just gone slightly further afield up there. But that's looking pretty clean now, I think. Just need to do it over here next, I think. Right, that one's fallen through as well. Again, solid. It's like concrete. It's like concrete. I think this is because it's going to an internal layer. And I think it's going to be a huge layer. It's starting to melt now, I think. That is nuts. Absolutely nuts. That is absolutely crazy. I think I'm going to try from the other side actually. Let's get some fresh solder on there. That has to be the most problematic solder point I've ever come across. That is crazy, it's just not moving at all. No signs of movement. Just going to end up damaging the board, I think, here. There is a connection here, you know, so we might be able to use that and just ignore this one. Actually, let's just see though, is it going to melt here? I don't know, strange. So yeah, I'm just going to clean up around this on the top side and bottom side, just leave that on. That is not coming off. Well, I guess this is the first time for everything. That's all the point. Defeated me. Yeah, hashtag defeated. I mean, I could put an absolutely insane amount of temperature, like 480 degrees on the iron, 480 degrees on the solid station. The PCB is already getting torn up around that pad from the heat that I'm using, you know, and I haven't gone at it for very long. So I'm just going to leave it. It's not a big deal. So that's the 373 socket. And we put the original 373 back in. That's actually alright. It's not looking too bad at all. Yeah, so slightly more beady solder points there, but that should be okay. Yeah, so I need to get some heat shrink over this and maybe some hot glue as well, so we'll just solder that wire right over that, like that. I'm going to shrink that and then get some little bits of hot glue, just like they've used here really, and just pull it away from pins, you know, hold it down like that, and then just glue that down. Oh dear, that's not coming off, is it? It's the same sort of colour as the PCB, isn't it? You can hardly see it because it blends in with green. Right, just get some small pieces of glue here, I think. It's one of those annoying things where I don't have enough hands. I want to get it away from pins. Yeah, like in the middle of those two there, like that. Get that over there. Hang on a minute, air flows way too high. You end up blowing the glue away if you're not careful. There we go, you can see what I'm going for, just a small little blob. I'll let that sat. Yeah, once that's dried now, I'll just route it away from any pins here where it's going to get pierced. Technically speaking, we're crossing the streams here, aren't we? We've got two wires right next to each other. Yeah, so I think I'll just stick one blob up here and that should be alright, really, because there's no way here it's going to pierce, I don't think, if I'm careful. Alright, there we go. Alright, just let that set. It's absolutely filthy. It's not even coming off just by wiping it there, it's ground on dirt. When I'll show you just a little bit, I can just move the cotton bud around there, look at that. It's filthy, so anyway, I'll report back in, I don't know, half an hour when I've finished cleaning this up. That is disgusting. The best thing to do on areas like that is use paper towel and then use the cotton buds on the smaller bits, but you can see it's filthy. The board is looking a lot cleaner now. I've spent, I don't know, 2 or 3 hours cleaning this, contact cleaner into ports. I went straight through, didn't it? Straight through the other side. Doesn't matter, it evaporates. But anyway, nevertheless, yeah, 1 or 2 of these pins are, yeah, not great. It's not going to get in there, is it? But the video port here, yeah, that was just a wee bit oxidised inside there. And I vacuumed this off as well. It's looking an awful lot better. There's just the odd bit of dust, and obviously around here, and these slots need doing here, so there's lots of dust in between them, and the actual slots themselves need doing. And there's the odd green bit to remove off the Zorro slots still. But hopefully you can see the difference there. It's looking like night and day, really. It's so much cleaner. Yeah, so that wire and resistor you saw me encapsulate there went to the, what is called the MMU slot. We've been calling it, or I've been calling it, the CPU slot on the 2000-A. But its original designation was for an MMU. Yeah, that wire with the resistor that we encapsulated in heat shrink there and shrunk that down, it went to, I think, one of the pins up on the right hand side of the slot, 4th one down I think, which was the CPU clock. So we just connected that up in the previous video there. And the old board, as I mentioned in a previous video, you had a slow RAM card, well actually fast RAM, but I think it fit in the slow RAM area that went into there, 512k. So that's why we only had 512k on board this early revision 4000. You can see the buffers here, one of which we fixed in part 1, and the one we're about to remove in this video here. And then there are 3, the top one's cut off here, more 245s for the address bus. You know, 16-bit data bus here, and then 8, 16, the third one takes us up to 24 bits for the address bus. So, you know, it's like a fully memory mapped slot. And on obviously the Zorro side is to the right hand side of that actually. So the left hand side of here is not buffered as the connections go. The connections will be going from the 68k CPU to this slot, but also from this slot to these buffers here for Zorro. the other thing, there's a number of other things, obviously. Battery, we'll do a battery mod, but also I'm going to remove this buffer, socket this one up as well. Just as I mentioned in the previous part, if one of these has failed, well, maybe the other one's going to fail at some point, but also going to fit the 3K3 resistor arrays under here, so that the Zorro is a little bit more stable, a bit more reliable, higher speeds and things like that. You know, well, not really higher speeds, because the speed is going to be the same no matter what you're doing with these things, but certainly from Commodore's perspective, they suggested doing that, and I've done that with every one of mine, and you know what, they run a lot better. The Zorro side, I find, is a lot better when you've got those 3K3 resistor arrays on there. So yeah, just some stuff really to hopefully improve this. I'm going to measure the DTAC when we get the CPU socket off. I'll measure the DTAC and is it VPA resistances there. You know, I think it's pull-ups, isn't it? Yeah, and we'll stick some resistors on for that as well. And then I'll perhaps retest it with the TF536. We may find after doing those things it works a lot more reliably with things like the TF536. And I'm going to use the solder station here to remove. And you could say just go straight to hot air. Well, then you've got to unblock the holes, but also the pins are not straight. Doing this is kind of straightening them out a little bit. Yeah, it's not freeing up there. Anyway, I'm going to free that up with hot air. But let's just go around and do a number of things at once here. So the socket, where's it gone now? It's here. Yeah, this is going to be painful. Look how bent over these are. Oh, God. Why did they do that? Why did you bend them over like that? They're so long as well. You could argue I could help myself here by cutting the ends off, first of all, I think. I mean, I might be able to straighten this up and put this one back on. If I can, I will do that. Anyway, we're getting there. I'll report back in a minute. Right, most of the solder removed from there, and I use the pliers just to, you know, snap the edges off a little bit. But you know, it's still not 100% free here. There's just the odd ground point here and VCC point that are just holding on. So I'll just preheat around the wire area. Yes, there's a hole in my pants there. And yeah, zoom in. And I'm just going to try and just pull it. I can feel it moving now. It's just one or 2 points. You can see most of the pins moving actually when I do that. There's one there that's not. Now it is. Just by wobbling like this, you'll be able to see the pins moving when they're free and not when they're stuck. And that just provides you all the information you need, really, to work out where to heat. There we go. So that's the connector. There's no through hole or anything like that. That came off really easy. I did mark the PCB a little bit with the desolder station. It's really hard to avoid that on this type of PCB. So yeah, under here just needs clean, I think. But all the pads look okay, so I think that survived the impact. Yeah, so whilst I've got the hot air up to temperature, I'm just going to remove that now. So we desoldered the pins on it a minute ago. Looking at the pin out for that connector there, they originally described that as a modulator here. So they must have planned to put some sort of modulator module into that single socket there, but then, you know, by the time the American 4000 was revised, we got the 2 slots. The thing down here is just the male 23 pin DB, you know, 23 basically, for the, you know, RGB connections and things. But the interesting thing with this page here that I just noticed, on the left hand side of that page, you can see here we've got some resistor ladder stuff. This is the DAC. There's no hybrid on this board. I hadn't spotted that. So if you look at the resistor sizes here, you've got 1K, 2K, A2000, A2000-A. I'm guessing they couldn't get a 4K and an 8K, you know, the exact sizes there. But those are, you know, like power of 2 step-ups for the individual bits, you know, R0, 1, 2, 3. This is the red channel here. So we talked about this stuff in the hybrid video. There'll be a link top right to that, and in the AGA Multifix series. And there's the transistor look to amplifiers we talked about in that hybrid video as well, and the cap there, the coupling cap, with a couple of resistors supporting that stuff as well. So obviously that got improved and put into a hybrid module. So it's interesting that, you know, this all predates the hybrid. You saw me do the same thing in the previous part, just using the extractor tool here to get it onto the underneath of the chip. Hold it in place, preheat around here, around the wider area. Just avoids delamination, and then start to focus in on the chip, in particular the ground and VCC points, because most of the points there are free, but that one and that one ain't. Now it's just hanging up this side somewhere. There we go, that off. So yeah, no pads or anything stuck on that. So I think we managed that. But yeah, that took longer than the previous one. The previous one came off really quick. But yeah, you can see just a bit of dust coloration there from the flux and stuff, but it's okay. And look at that under there, it's really dirty under there. Wow, that needed cleaning. I mean, the thing is with something like this is the thing, you could argue you're going to need to remove everything around here, really. You know, you could just go on and on and on with a repair like this. You know, I flooded IPA under here previously. Let's just give that a bit of a wipe. Yeah, I'll do exactly what I did with the other one, you know, get some flux on there, some desolder braid, remove that crusty solder. And of course we need to do the same thing here. So, clean with some IPA. You can see how much cleaner the board is there. The board is incredibly clean now. There's the odd bit. Yeah, so this old connector here, I can get it back on, actually. I can get that back on, because all the pins are up and straight now. It was all just a case of, it just got bent the way it was, you know, because of the position the pins, you know, it was just like slightly bent one way. So yeah, if I straighten all these pins now, we can, in theory, just get that back on. There's nothing wrong with it, it's the original connector, why not? You know, they're protruding through exactly the right height on both sides here. Yeah, and you can see after just, you know, putting that back on, it's totally flat and flush, and the pins are all perfect here. So I can put the original connector back on. It just needed to be pulled off, you know, slightly straightened. I think what I'll do, rather than bend these back over, I'm going to trim them all down actually after I've soldered it in place. Right, I'm just going to use some magnification and inspect those, and then just reflow to get equal sizings, but anyway, that's done. Yeah, that's not too bad. So yeah, just the odd bit of markage on the PCB, because that was pretty hard to get off. Right, so I cut pins down the connector. The next thing is the 68K socket. I might actually repin the pins at the bottom that need doing, rather than replace it. Right, I used the engineer desolder pump from Andrew, little boy there. Yeah, the desolder station I switched to halfway through, and I was getting nowhere with it. The desolder station's terrible with pads, where the pads are this small. I've had this problem before with some of these boards. Anyway, let's just now have a bit of a brush this way, because there is the odd particle. There's 3 solder points there that have been reflowed by someone in the past. Anyway, I've done that side, I'm just going to do this side now. So pliers, just grab the pins, have a little pivot on 2 or 3 at a time. Now let's just see, it's probably not going to be free. And what I may do is repin this actually. I'm just going to see if I can get some replacement pins. Yeah, that's not free, look. It is not free. Yeah, not levering a lot, just general like that. not free. Yeah, you can see here these pins are free, something here is not. Oh, they got that lever in the middle like that. It's not free here either. I think I'm going to get the hot air onto this again. I'm just going to pull the socket from the other side and heat with hot air, because otherwise I'm just going to destroy it. The board, that is. Could cut the socket up, but there is a risk when you cut turn pin sockets more than dip sockets in terms of losing pads. That's it, it's off. That was painful, absolutely painful. So underneath there, yeah, it's not bad, is it? This is a thing. Did that really need replacing? Probably not, but it was a good idea. Yeah, so you can see I warped this slightly by pressing there. We've got a few pins broken off there. Yeah, so that socket, it was not that bad. Look, gold, 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 and just a bit dull here. But anyway, I think it was a good idea to replace it. And believe it or not, I will keep that and repin it. So the pins that are broke off, like that side's alright, apart from down here, I would replace, I don't know, that many, 6 or 7. And then on this side we've got 1, 2, 3, 4, 5, 6 where the pins broke off. And these ones here. Next thing I'm going to do is use a fiberglass pen and just go over these just gently. Go over these wires here as well. In particular, the pins at the bottom. Wipe around that with some vinegar. And we'll just heat the braid and have a little slide up there. Alright, that's all it needs. No issues at all there, it looks good as new. So pin 1 is at the bottom. Yeah, perfectly flat and flush, that should be good. And there we go, brand new CPU socket installed. So I'll do exactly the same thing around this 245 here, a little bit of flux on the pads. Use the braid and just have a little bit of a slide, being careful not to touch these sockets and things, obviously. Yeah, inspection magnification, other than the odd solder mask markage, it's fine. So we can get a socket on there. Yeah, so we've got the original CPU, that was really hard to get that in. So those new sockets are really good actually, the best ones I've come across. They came from RS Online, those sockets, and the original LS chip there. So let's now give that a try, it should work. We need to clean up obviously, but I'm keen to just test at this stage now because we've done quite a few things there. Yeah, sanity check. Yeah, because I got my ROM on my 2000 ROM the wrong way yesterday. I took it out to test this, and then when I put it back on the other board, I thought I was pin 1 at the bottom, but it's not on the later boards. Or the later boards, the F4, F6, they flipped the orientation of that round, so just be mindful of that. And my ROM got dead hot, but it did work. I didn't kill it, thank God. I don't seem to have much luck with pin 1 on ROM sockets on Amigas, do I? Right, let's just switch that on. Please work. Hey, it's booting, I think. Not got a disk drive connected at the moment. Hey, so that's brilliant. Yeah, so all going according to plan so far. That's nice and straight. The socket's new. That socket's obviously new, and it just means that these are easy to swap out for either ALS or LS ones again. So get the resistor arrays under there next, and the two sockets. We'll do the two things at the same time. I'll finish cleaning up after that, I think. But once we've done those two things, I'll just retest CPU cards here actually to see if the resistor arrays make any difference. I mean, in theory they shouldn't do, because it's just on the Zorro side. I think we may need to do the DTAC and VPA resistors. And whilst I was looking at this stuff to Gary here, because I think some of this logic doesn't feature on the later boards, it's merged into Gary. There is no Gary. So, you know, one or two of the floppy functions, maybe the motor on, signal and stuff, comes from some 7.4 series. I noticed this is the thing I noticed, internal serial. So later revision schematics refer to this end on the silkscreen, I think, as the infernal serial connector. And I think that's a typo. I actually think someone got the T instead of the F when they were typing it, and it became known as the infernal serial connector instead of the internal serial connector, because you've got the internal pin header there, and then you've got the external serial port there. I mean, I could be wrong. Maybe they did call it the infernal one, or someone thought it'd be funny to change the T to an F. I don't know. But again, there's a little bit of history there, isn't there? How it, you know, originally it wasn't infernal. At some point it became infernal, and I think because of a typo. Yeah, so I don't think these feature normally. There's a couple of flip-flops here, and a transistor, some resistors, some more gates and things. In use and ready, signals and things for the drive. I think Gary perhaps does some of that stuff, but on the back of my mind I'm thinking something to do with the motor on signal is done by Gary. But yeah, this board never had a Gary. To get these slots absolutely straight is solder just 2 points, get a card in, it was a wee bit stiff, yeah, then flip the board over overhanging like this, and just reheat those 2 pins as you hold the card. And then I felt the socket move when I did this back one here. Just alternated a couple of times, and then you end up with it's super straight. Yeah, so solder the 2 points, and you can look at it and go, oh, it's nice and straight. But you may find, I mean, it might be nice and straight, but you may find it's it feels tight. That does feel tight. Very tight, in fact. But those slots have never been used, so that's not probably the issue. But then, you know, just heating these points here. It moved. Did you feel that? I hear that. Just making sure it is flat. But it moved. Because now it's kind of in a more natural position. Now, of course, it depends whether your card's straight or not, but trust me, this card is straight, so there we go, it's come out a lot easier now. After adding those resistor arrays on the underside, it's giving me some stability already. The TF536 just booted straight up, and games and things are working on it. It was really flaky when I tested it yesterday. So, it's strange, because they're on the Zorro data bus, but they're not just on the data pins. I think the way it was explained in the guide was to fit them on that whole side. Yeah, they go on those resistor arrays go on the side where the ground is, so I'm not sure what pin 2 is that, or pin 1 rather, is that the output enabled or the direction pin, I'm not sure. But nevertheless, the resistor arrays are on there. One of them was a bit short, well, both of them were a bit short. I had to put a resistor on one of the data buffers there, and the other one has got 2. So I'll show you on the underside. Yeah, you could argue it's a bit of a bodge, but the original mods from Commodore were a bodge to start with, to be honest. Anyway, that's working. I'm pretty pleased with that. Let's power cycle it, see if it boots again. Right, so that's booting from IDE. Obviously, we've not got the original CPU on at the moment. We're using the 536, and I haven't done any mods to any of the resistors. I haven't fitted anything on DTAC or VPA, VPL, whichever. I can never remember which one it is. And there we go, it's booted again. So you know what, I think the corrosion under that data bus buffer could have been part of the problem as well. You know, now we've cleaned that up. I bet that's what it was. So yeah, at least with the few mods I've done there, it looks like he can use an accelerator card without a problem, as long as it's one of the ones that doesn't need the 68K in the socket at the same time. So yeah, coming back to Gary again, the ROM output enable is done by Gary. Well, there's no Gary on this board, is there? It comes from this PAL here, PAL N. And if you look down here, you've got ROM E, ROM enable, and follow the trace down, it goes all the way down to the other page here where you've got the ROM output enable there. So yeah, the ROM address decoding was done in a PAL, you know, a discrete PAL here. originally, before it was merged into Gary. There's some cast stuff from one of the pals there. I'm not sure how that was done on later boards. It may have been done by Gary as well, actually, now I think about it. Because, yeah, I think one or two of the, or maybe even Fat Agnes, it's one of the two there. So either Fat Agnes or Gary replicates the functionality of this PAL on later boards. So right now it seems pretty solid with the 536. I think what I'm going to do is test it with the 520 again, and the AT bus card, because the AT bus card was having real problems with different compact flash cards. I could hardly get it to boot at all. I'll bet that this now works with that. There's still a bit of greenness here, I need to clean that. And we get Liv2's got to go fast RAM card in as well. So, RAM, yeah, I talked about this before, try and get it near to the CPU. I just found from experience that with the RAM cards, for some reason, these things are always happier with the RAM right next to the CPU slot. Right, let's get the 520 in. That's got solder coloured edges on that adapter, I think. That's all. This has got gold plated. That is tight. Let's try that combination. Yeah, a yellow screen. It doesn't like that, does it? No, sometimes the 520 here needs a power cycle. Let's try it in a different slot. Nope. Let's try the reseat at 520. Yeah, the Liv2 board isn't working as things stand, I don't think. Now bear in mind, the firmware I've got here, it works better with the ALS chips, so you know what, this may need ALS chips in the Zorro data bus area. I'll try with the stock CPU again, just in case I've killed Liv2's board. Yeah, Liv2's board doesn't work now. Yeah, full disclosure, different Zorro cards are now struggling with those 3K3 resistor arrays on the underneath on this board. It probably needs more mods, so I'm going to remove them. If Conrad wants to fit a couple of resistor arrays to get a 536 working, he can do, but I wouldn't do that on this board unless you do all the other mods, because other problems occur, like say, you know, like the Zorro slots don't, you know, they're not really that useful. It's not booting from IDE on a Zorro slot now, even though that board is reported as working, but it's also showing the RAM as bad, and the RAM isn't bad. Yeah, so I'm just going to remove this stuff with hot air. It's far easier to get it off with hot air rather than trying to remove the bits of solder that are there. Right, in true me fashion, I'm getting in a real mess here. I'm testing now with my Rev 4 board and Liv2's card, because you know what, there's a problem with Liv2's card. I think those resistor arrays aren't the issue. Maybe as a result of removing the CPU or that second buffer chip there was a trace damaged or something like that, I don't know. But I mean, if I list and test the regions, I've just tested Liv2's card here, and I just reflowed literally everything on Liv2's card before I got to this point. And this is why I'm then, okay, let's test it. I should have tested it on another board first, really. And it's fine, it's going round fine, there's no issues there at all. It's gone round the full range once. Let's just hold down both mouse buttons. What I want to do is just see what the ID code is. It was 1063, I think, or 4063, I forget now. But it was 63 on the end. Let's just see if it's reported the same here. It's not. Yeah, the manufacturer code is completely different. Maybe there's a data bit not getting to the slot there, you know, because we took off that second 245. So it's took me about an hour and a half to work out. Obviously, the RAM board works alright. I cleaned it up, and yeah, that's working finally, the machine. And I thought, well, so what's wrong with this? So I inspected on both sides, looking for maybe a particle of solder, inspected in the slots, tested connectivity on the data bus to these buffers here, because I thought that's the thing we'd just done. We took that off and we took this off, so maybe we got a data connection or an address connection not getting to the slot. The clue there for me was if I set the card to 4 meg, diagram would detect it's 256K, and 8 meg it would detect nothing, and I'm like, well, there's obviously a bit there's some bit somewhere when you've got it in one mode, a couple of bits are set, and it's picking up one of them and going, it's 256k, no it's not. So you could from that look up the spec of the auto config side of things and work out which data bit it is. But then I thought, well, let's just test the other side of these data buffers here, in particular this one, and see if there's any problems. Well, it's hard to find the connections to the slots. But then I thought, well, hang on a minute, Occam's razor stuff again, simplest explanation. When we had the resistor raised underneath, we added quite a lot of solder. It may have wicked up the pin and joined to a pin next to it, or a wire or something. So let's just test pairs. So, you know, that pin and that pin, move to the next pair, next pair, next pair. As soon as you get over here, hang on, 2 pins are short. That's what it is, 2 of these pins are short somehow. And these are the output data bits, the Zorro side. Yeah. So that would explain it entirely. Where the actual fault is, I honestly don't know. I think what I need to do is desolder this socket. Maybe just desoldering might solve the problem, because if there is a large blob of solder from when the arrays were on, that might be it. Something simple has turned into an absolute trauma. And the reason I thought there was a problem with this card of lids is because you can see the slots on this old board. It's near impossible trying to get cards in there. I don't know why. It must be the tolerance must have been improved when they put different sockets on, Foxconn ones or something. Anyway, where is it now? It's here. So it's this one up, it's the top side of it. So I'm just going to desolder the pins there. Right, I desoldered those pins and the short's still there, so it's got to come off. I just noticed there's one pin not desoldered here, top left there. You know, solder particles, well, that's the answer probably. It's going to be something like that. It could be when I used the braid, maybe I didn't spot there was like a strand of braid or something attached somewhere. That's a possibility here. So let's have a wobble. Oh, hang on. There we go, it's off. So the socket's off, I'm just inspecting the socket. Well, the socket's alright, there's no issues there. The world's smallest particle of solder. Let me put you on macro. It's like somewhere here, there's like a little silver line. I think that's it. Let's just see if the short's gone. No, there's a short there. I don't understand why there's a short. Oh, God, maybe I'm barking up the wrong tree and it's in one of the slots or something. I don't see any solder there. There's no... Oh, hang on a minute, there is. So when I was using the braid, I was getting stuck. There's a single strand here. Single strand. You can't even see it, even on macro, I don't think. You can see it there now. Right, let's try that again without a RAM card. And then I will stick the Bluetooth card in. Beautiful floppy, I think. Yeah, there we go. Right. Has that been on macro the whole time? Yeah, I'm not sure if that's been on macro the whole time, but we're back up and running. So I've tested a number of different things here. The 520 works okay, Liv2's board works okay in the Zorro slot with the 520 or the 68k. I'm now booting with the 68k and the AT bus card, and that works. We've got IDE. Yesterday it was near impossible. In fact, it was impossible. I couldn't boot from the AT card at all. So those 3K3 resistors, they make a huge difference on the Zorro data bus. If you've got a 2000, you've got any problems with certain cards, have a look at sticking those resistors on there. I'm very pleased. Right, next steps with this. That socket really needs replacing. If I'm honest, it was really green when it first came to me, and I've cleaned that chip up a few times. It's not caused any stability issues or anything like that, but you know, the legs are dull, the socket is greeny, even though it's been cleaned a number of times. So we'll get that off. Battery, let's do the battery next. So ground is down here, I think. Yeah. So if we test to these terminals here, the ground is the single one up there. These two are the positive. And if we test from this resistor, I guess this is what feeds it. Yeah, so we've got dead short there, 4K7 there, a dead short there. I think what we'll probably do is take this resistor off at the very least here. then just measure the voltage on here. I've measured here a minute ago, it's like about 4.6 volts or something like that going to the positive side here. So it's providing a voltage, perhaps through this diode and through this resistor, to the battery. If we remove this, it should then be isolated. You know, there shouldn't be any voltage on here. At that point we can fit a diode here. We may need to remove this diode, although well, it depends which way around it's wired. I'm going to remove that resistor, then test this diode in terms of its relationship to here. Maybe remove that diode, clean up the pads, clean up the odd pad around here. But you know what, whoever did this, maybe Conrad, he's done a good job of tinning all this stuff up. It's pretty good. It's just here that's a bit awful, and this jumper, it's a solder blob, it's corroded, so we'll redo that as well. 2 point something volts on that side, and here, yeah, 2 point something volts. I'm going to remove that diode. That diode is probably faulty, which is why it's acting a bit strange. Anyway, we need to remove that anyway. Cleaned up around here a little bit in terms of tinning those traces and pads there. Just get a little bit of flux on there. That's just a solder point, but I don't know, you can see it looks creamy coloured, it's white. So yeah, let's just, I think it's a solder point. It's not melted, is it? It's like concrete. Someone's installed concrete in that jumper position. That's hard to believe that is not melting. Right, the iron temperature increased by 60 degrees. Actually, let's see if it's going to melt now. Let's just try and get a bit more solder on there. Starting to melt. There we go. I think someone's used a different type of solder there. That was why it looked brown. I don't think it was just about corrosion. Right, I'll decrease, well, I'll tell you what, before I decrease the temperature, let's just get a wee bit of flux on there. And looking at that, that's the enable for the charge, isn't it? You could probably leave that resistor and stuff in there. That pad's come off, look. Yeah, that pad has just shifted. Let me just see what's going on there. Yeah, that pad is toast, which is no surprise really. You could argue if I'd reduced the temperature a bit there after we removed the solder blob, it might have been alright, but you know what, I still think I would have lost it with the friction from the braid there, just a slight heat. Anyway, it's not a big deal. I can just fix that with a piece of kynar now. Right, so I'll get the diode on and we'll join up to that pad, the band cathode, towards the bottom. Let's just try and pull that into position. So yeah, we've just joined it across there to fix the missing pad. Someone's bound to pipe and say should have used a wire with some protective covering on it or something. I don't think so. I don't think it's a big deal. There's so many exposed bits and things on these and wires and things anyway. That's going to be fine. We could have, of course, like I said, soldered it into this hole here and then gone to there and had a wire across there. I could have even done the wire on the underside. That's a way to avoid doing that. But anyway, it just tells a bit of the tale. It's obvious to someone looking at it what's actually happened around there. So yeah, this whole area, it's not very clean, is it? Using a dry cotton bud like that, you can see you kind of eventually polish an area that's dirty. You know, that bit there's looking nice and shiny. Anyway, I'll finish cleaning up around there after we've done this second part of the mod here. So the next thing is to get a button cell on there. So we've got our button cell. We're not bothered about that thing. I tried to remove that earlier. The negative is up here. The positive is the little edge on its own. Positive wants to go down, up, down here. So we need to, just get the negative through and then either fit it that way or that way. I think I'm going to go that way actually. Yeah, just solder that into position. Yeah, this here though is still sort of sticking up a bit, so I'm just going to try and trim. That'll do. There we go. So I'll just flip that over, solder it on. Yeah, it looks a bit of, hang on, let's just make sure it's through. Yeah, it looks a bit of a state. It always does around these contacts when someone's been struggling to get the things off, and I did. And I think what's going on here? Why is that solder absolutely not joining there? You can see what's happening here. It's like that pad's like, nah, you're not soldering me, mate. Let's just pull that back off. Yeah, the corrosion has just negatively affected the surface there. It's just, and I'm doing this left-handed, by the way, of which I am not. Yeah, whatever you do, don't just install another NiCad or nickel metal hydrate. Do not do that. There are some people out there who might be alarmed at the fact that I've removed the resistor and the diode. But this board is going to be used. It's going to be used and loved for years to come, until eventually it dies. It's not a museum piece. I'm sure there's probably better examples of this motherboard out there that, well, would be in a museum. And we're back to the fact that if you went to a museum to see a computer like this, the last thing you're going to be doing is inspecting the motherboard and going, oh, it's not stock, someone's fitted a diode there instead of where that resistor was. Someone's bodged on a CR2032 holder. That's outrageous. It's not historic. That is not soldering. What is going on? That's it. And it's gone through. So the other pin is, hang on, which one was it? Hang on a minute. Why is that not through? Oh, it's that one. There, yeah. I forget there's two pads, it's the top one here. Again, that is not soldering, look. It probably just needs more time, because you know what, thinking about it, these are on the internal layers maybe. And that's the thing, they absorb a lot of heat. There we go. I think that's all it was. I think I just wasn't patient enough and giving it long enough for the heat to pass through. So, yeah, so you won't have seen the video yet, but here's a battery I bought earlier. It was a brand new Panasonic battery, and I put it into something I modded, and I didn't measure the voltage properly. And it drained and drained and drained, and within an hour it was down to like 2.7 volts, which is why I've written on it 2.7 volts, because rather than throw that away, we can use it for something like this. I can't send this back with the battery in, because it's going airmail to New Zealand. So let's use it here. So anyway, let's power it on first without the battery. From ground down here to the positive, 0 volts, look, nothing, yeah. And on the cathode side of the diode here that goes to the chip, real-time clock chip, you can see we've got 4.7 volts. That shows that while it's powered, the real-time clock chip is going to get that 4.7 volts roughly. But what it's not doing is it won't be connected to here, yeah. And then if we switch it off, get our battery in, if we measure again on volts DC to this pin up here, that should now be powered. There you go, 2.357 volts. Just watching it. Yeah, it's going down a little bit, down a little bit. Bear in mind this battery is pretty flat. Now we'll do that to start with in terms of a little bit of drop, because there's going to be a capacitor, maybe this tantalum here, there's going to be a capacitor around there that charges up. It's probably like 10 microfarad or 22. So you will get to a point where it stops charging. And as I showed in another video, if I switch the power on and we measure that, it'll shot up to 4 point something volts. There we go, that's now taking it from the motherboard instead of the battery. So it's going up 2.738, 2.739. It's recovering because the voltage on its cathode is higher than the 0.125 forward drop it needs to switch. It's like a one-way street. It really is that simple. It's like you've got a no entry sign at the cathode side, yeah. So traffic, power, yeah, electricity cannot go from the cathode to the anode, yeah. The band indicates the cathode here, yeah, the negative side. Its positive side is anode. Power can go, electricity can go from the anode through the cathode. Only if its anode is higher than its forward switching voltage. Yeah, so the side that you've got here, the potential at this side here at the moment measures 4.7 volts. Yeah, so that is higher than what we got here, because this is 2.7, so it's just switched off. Yeah, it's this one-way street traffic, and it's not just a one-way street, it's a one-way street, but now we've got, like, you know, a stop sign, if you like, at this side here where the battery is. So yeah, the battery is not even connected to the real-time clock here. Yeah, we switch it off, the stop sign goes, because we've now got like 0 volts here for, you know, just after. There is a cap, so it takes a few seconds for that to start to switch actually, but as that cap drains down to below the, you know, the switching voltage we need here, it will then start to, you know, traffic to conduct again, you know, traffic to come through from its anode to its cathode through to here. And if we measure that now, we should see the 2-point-something volts, and it'll be dropping a little bit as it charges that cap back up. There you go, 2.338, 2.337. Yeah, I know we've done batteries to death, but hopefully the one-way street thing and the stop sign when it's not switching because of its forward switching voltage is, you know, the condition's not met there, if you like. It's got a higher potential on its cathode than its anode. It won't switch. Hopefully that'll just help you understand that sort of thing. I've just given these slots another go with deoxit, use the tool here just to scratch any tiny little bits of green off the very tops and edges. But the pins themselves are really clean, but I will clean them again with some IPA layer and hoover it down at the end. If we now get this chip out here, yeah, you'll see, well, you can see nothing actually on the actual chip itself. It's like, look, it's just like a plasticky melted surface. I don't even know what that is. I am guessing a gal. And look at the legs, they're just like dark grey. And even though they've been cleaned, they've gone dark grey again. I'm going to tin those up, we'll clean them, tin them up. But ultimately it's the socket. Kind of looks a bit really white and furry. So, I mean, I've cleaned with the deoxit, I've cleaned with a contact cleaner a number of times there. And it's not caused me any stability issues or anything, but it needs to be swapped. It will just eventually start to corrode these pins, I think. The very fact that I cleaned these up and they were like silver, and then reinstated it, and then they've gone like that again within 48 hours, tells me that this is corroded. This needs to come off. When you've got greeny solder points on the underside of the back end of this here, just use a wire brush, yeah? Don't press the board, scratch the board. Just hover over the board and scratch the pins. Like that. I'll probably want to use hot air to free it up after I've got the solder off. But yeah, those are now not as green. They're still a bit dull, but they're not green, which means it should come off a bit easier. Alright, everything apart from that pin there is pretty desoldered, so I'm going to use this again, get it underneath the socket. I need to clean up around these resistor arrays here, and yeah, you can argue it's a bit bodgy having 3 different resistors there to compensate for the fact that those resistor arrays are not the correct size. Finish up down here where it's stuck. That's it. So yeah, you can see under there, it's pretty furry. I don't see any pads or through hole or anything. So I would say these boards are really good quality actually. Oh, look at that. Ouch, do you think that was a good idea? And this is the thing, so seeing this, you may want to remove all of these slots. It's just one of those things that, I've cleaned and cleaned and cleaned. Not as thoroughly here as I have done with the slots. You know, I've got IPA under there, blown it under with hot air. I've done it a few different times, 3 times, vinegar IPA, etc. But yeah, you can see what happens. This gets under there, gets between the pins, you get conductivity, and weird things can happen. And just inspect to make sure I've got none of them blooming strands, because you know what I could have done? Could have joined 2 pins up again. It's that braid is awful. Not all braid is the same quality. Yeah, and inspecting really closely with magnification, there's no damage there. They're all freshly tinned. Right, so pin 1 is on the left there, pin 1 is down here actually. It's another one of these repairs that never ends. Not everything like this needs to be a Picasso. You just got to do the best job you can with the tools and components you've got. But you know what? That's not too bad, is it? Right, so that chip has been pretty thoroughly cleaned. I'm giving it another clean now, so with some more IPA. And I tinned the legs up, got some desolder braid and flux, and tinned the inside and outside of the legs. Yeah, if you look at that light, can you see? It's just got a smooth plastic surface. Yeah, anyway, the legs look alright on the inside and on the outside, I think. So let's get that into the new socket and see if it still works. It may not work. Yeah, it should have been a simple process, this, but you never know, the heat could have just damaged that chip. Or we could have some problem as a result of that socket again. So we've now got the real-time clock battery on there. We can set that. It's progressing, I think. Yeah, that's a good sign. Yeah, so I think that's everything. We know the serial parallel's alright. This doesn't have a filter, but the audio works. Right, so I had a bit of a clean around some of the caps and things around here. There's just an odd, you know, ground point that was a bit fuzzy. So everything's looking pretty good. I do need to toothbrush around this area just to finish off and around the RAM and clean the ISA slots. But the next thing I'm going to do is get the 536 back in, and I'm going to test it with an AT card, the 286 one, and maybe a VGA card in one of the new 16-bit slots there, and just see if that boots. It should do, in theory. Live 2's card in 4 meg mode, the A2000-A and a VGA card. And the Amiga has booted up, and PC, yep, PC's booted. No worries at all. So I've got VGA, it said 16-bit mode there, I think. Well, it's configured to 16-bit mode, that card. Anyway, it's working. Yay! I'm pressing F5 here now. I just remembered the config.sys has got EMM386 in it, I think. There we go, EMM386. It's a 286. I was wondering why it was freezing on the Hyman bit, and that's why. Just Control-Alt-Delete it. There we go, it's booted this time. Yeah, hard disk speed is not very fast when it's provided over the Zorro bus from the Amiga. 68.5 is marginally faster than the later boards, actually. Yeah, it's not bad. It's almost up to the speed of an XT. You'd expect it to be more, considering it's an AT. But obviously you've got like 0 average seek and 0 track seek. That's where you gain. Yep, fantastic. That's working. Right, so the 47 microfarad capacitors have arrived, and now I'm just going to fly through this, just show you a few highlights, 1 or 2 capacitors here. They're mostly, as far as I can see, 47s. There's probably going to be the odd 22. Yeah, so I just got the first cap off here. It was a 22 actually, this one, with the ground down towards the bottom. So I'll do the same thing for each one here. Just have a little clean on the surface with the fiberglass pen. The nice thing with this is obviously I can clean right in and around these capacitors now as I've taken each one off. The ground here is towards the bottom. It's actually got an indication there for the positive, just in the same way as the chip. There's like a little notch in that corner. So yeah, let's get that through. There we go. I actually pulled that one out. I soldered the pins first, but then just pulled it. And then my usual circle top in red, so I know I've done that one. Yeah, and I thought I'd show you this one because it's right next to where the battery is, and you know what, if that's survived, everything else will have done. And it doesn't look too bad, so I just circle around the pad a little bit. the negative was towards the keyboard connector here. Yeah, positive is indicated there. So I'll jump to the end result in a sec, unless there are any that, well, need your attention really. Yeah, my solder had run out. Now, when I was back in the trade, a local school I did work for, mostly on Acorn Archimedes A2000s, I think it was, they brought me this. They were like, our course has finished or something, I don't know, they didn't need this anymore. And they brought me all these little bags with loads of solder and stuff. I think it contains flux, it might not do. Yeah, and I've never used it. It's just all been sat in this drawer here, piled up for years and years. But now that tube is out, this is where, when you get one of these solder dispensing tubes, it's worth keeping it, because if you've got something like this, you can just make use of it, any offshoots and things, bits of solder you've got. And then because of the diameter of this, the pen will obviously go inside that. So what I will do here is just literally coil it around, and we'll start using some of this solder that, let's say, kindly came from, I think it was Arnold School. I'm pretty sure that's where it came from, in the Flower Coast. Yeah, this right hand side has desoldered better than the left hand side. And then grab the cap on the underside, heat the pin that was very free, so that's this one, wobble it, I can see the pin moving. Just keep wobbling, keep wobbling, keep wobbling, keep wobbling. It's wobbling, it's free. Yeah, and then do the same on the other one. Yeah, heat up to temperature. As soon as you just wobble a little bit, as soon as you start to see it move, and let's try that again. Yeah, I'm just going to pull the right hand side out. The left hand side is not coming out. And that one there is the hardest one I've come across, and it's going to be this thick rail here as well as the internal layers. So I think what I'll do with this one is just add some fresh solder and pull it through. Actually, just to make sure I get the right cap here. Yeah, always make sure you pull another right cap if you're going to do the heat and pull. And obviously don't pull until it's free. So it's starting to wobble now, the pin's wobbling, I think. Yep, it's free. And they just manipulate it left, right, there we go, it's coming out. And then with the solder still pretty hot there, heat it up just for a few seconds again. And the solder, there we go, completely unblocked. And the final two caps here. So yeah, very dirty under there. Now these ones are on the power ports, they're not audio, definitely not audio. And the four over here, I think are probably audio related. I just can't work out the connectivity. I did have a look at the schematics, and the schematics don't match. So I don't know, this is like a revision that my early 2000 schematics don't seem to match. So I think I'm just going to go for it and stick the TF536 in and boot some games and demos and things and have a play around with it for a period of time. It's interesting how different this system sounds because of the difference on the audio section there. You know, it's not got the filters. Or it probably has some filtering, but it's probably like always on to a degree. Right, plugging a cruiser in. And let's just have a play with it really. Oh, hang on, I need a keyboard. Don't you just love it when you've got these games on the Amiga that need a keyboard just to be able to start the game? F1. I noticed the keyboard socket perhaps needs a clean as well. The 5 volts doesn't make a very good connection, just occasionally when plugging the keyboard in. And I can tell because the LED does not come on that 500 keyboard. I was a big fan of the arcade game of Cabal. I'm not really sure how you say it. Is it Cabal? Yeah, a Cabal is like a group of like-minded people, isn't it? It's a bit like a clique, I guess. An organisation to do with spying or something, I don't know. It's a cool game, the arcade version though. I think it came in 2 different flavours, didn't it? Originally it came with a trackball. I think that was the version I played. But there was like a modified ROM or something that arcade operators got hold of, which allowed use with the joystick. It's interesting, quite a lot of games work with just 512K chip RAM, but there are a few little on WHD load that will complain, say you need a mega chip. So yeah. Yeah, one complication with a board like this is upgrading the Agnes. It's not that straightforward, is it? I'm sure there's a way perhaps to do it, but like the Fat Agnes, the Square PLCC chips, they had the clock gen stuff on board. Maybe you could just bypass that, I don't know. You'd need some sort of adapter though from the dip socket of the current Agnes to a PLCC, and yeah, I'm just not sure what problems, if any, it would create because of the stuff that the Fat Agnes provides that's elsewhere on this board. Yeah, so I mean, I guess in that sense, if you're looking for a 2000, you're better off with one of the later boards, really. It's more of a collector's piece, this. But everything works fine on it. Something that did strike me as well, because there's no Gary on here, this would be really easy, just looking at it, to actually recreate Gary, because you could just look at the 7.4 series on there as it stands on the board. The one or two PALs, the equations are available for, I think, or they've been reversed, one or two. So it'd be really, really easy to recreate Gary, actually, just looking at the stuff on a 1000. And if you've seen previous videos I've covered on the 2000, you know, and the 4000 stuff as well, 245s, yeah, they often fail, don't they? And they fail on the data bus side. And you may be wondering, why have we never seen these ones fail here? It's because they're on the address bus and some of the control signals. And it's about contention, it's about things fighting on the same bus. Yeah, you know, you get a lot more activity on the data bus, bi-directional, because it's communicating. It's got to be bi-directional. You know, it sends, you know, it wants to read, it wants to write. So you've got direction, you know, traffic going both ways in and out of these. These ones here, the kind of, even though the 245s, for the most part, apart from the control signal ones, the address bus ones, which there's going to be 3 of these because it's 24 bits. They're going to be unidirectional. 244s could have been used there. I think, yeah, I think they're all 245s here, but they could have used 244s. Don't know why they used 245s. It may be to do with bus mastering. There may be things on this card that actually can control the address lines, you know, for DMA stuff. So actually, you probably do need 245s there. But the point is, you get a lot less problems for contention stuff on address lines versus data lines, because generally there's more things communicate on a data bus than there are on address bus, generally CPU or bus master devices, you know, things that are doing a DMA. Those are the only things, and you might have less DMA cards or DMA capable stuff in here. So, you know, for argument's sake, you may, for most instances, you may just have the CPU controlling the address lines. You may have one device on there that is occasionally doing DMA stuff and needs to use the address lines. And when something goes wrong with a card that's in here, let's say, I don't know, it freezes, it glitches, it could be a problem, it could be a fault on the card, but it could also just be a glitch. A glitch occurs and the card freezes and it's writing something out to the data bus. The CPU's trying to control that data bus, it's trying to drive it, and this is driving it, you know, the card that's failed, bang, you get a fault. It's that simple. And that's another point as well that people don't often realise. Software can kill hardware. Yeah, you get software faults, something glitching, locking up, and you just leave it there. Yeah, that over a period of time could kill something like this. Yeah, that's more or less what we saw on my 4000 when I was testing the SCSI, an extended overnight sort of, you know, hot cold cycle, doing a load of stuff with the SCSI. It crashed in the early hours, and like, I don't know, 3 or 4 hours later I came to look at it. It killed something. A data bus transceiver had died because a software fault probably occurred, a glitch somewhere, something locked up one of the cards, yeah, and it was unattended. And of course, it's just a matter of time. Sometimes things like that can happen straight away. Sometimes you get a failure, you know, from software and something locking up, and the data bus, you just get, you know, I don't know, a weak transceiver, a pin on one of those can just, you get a failure. Yeah, transistor fails. But more often than not, these things have got a tolerance and they can sustain, you know, shorts and things like that, lockups from software going wrong, and you just power cycle it and it'll be alright. But yeah, you may not have realised that your software can kill your hardware. And a side note, before I get some hate messages in relation to what I've just pointed out there, yes, there's ways that systems like this can deal with that. You've probably got some, I think you have, bus error stuff. So the 68K processors and the 6803, 020, 40, etc., can detect a bus error. some sort of problem there, and it'll reset the system. So yeah, in those sort of circumstances, that's often sometimes where you'll see a reset. Why did it reset? Well, if it's not power, maybe someone's glitched out somewhere and the system's detected a bus error and reset. And when you get a reset, everything's starting hopefully from a level playing field again, unless you've got a hardware failure somewhere. And of course, in other systems like the Neo Geo, for example, you've got watchdog hardware as well. So if you run into a situation where a bus transceiver failed and your CPU suddenly can't communicate, the watchdog stuff's going to, it's going to fail. It's not going to be resetting the watchdog timer, and then it's going to do a hardware reset. And yeah, in that scenario there, if unattended, it's just going to keep resetting because you've got some hardware failure somewhere. But anyway, the point is, yeah, there are things that protect against that sort of thing. And of course, the bus transceiver itself protects against certain types of failure, doesn't it? Yeah, it's it's a buffer in between one side and the other. So yeah, by virtue of it failing, it can protect other things in the system. Such a great port, this. One of the first games I played on the Amiga, actually. I went round to a friend's house when I was at college at the time, technical college. And yeah, one of the guys, Andy, all day he'd been showing off his Motorola 68K CPU that he kept, proceeded to take out of his pocket. Yes, he actually took it out of his board, brought it into the class, and had it in his pocket, and every, I don't know, hour or so, get it out and show a load of different people that entered the room. And I was like, I'm sure that's not going to work by the time he goes home at lunch. Because of VSD, there's no, he didn't take any precautions or anything. There's no anti-static foam or anything. He was just had it in his pocket. Once or twice he got it out. I was like, oh, hang on a minute, and straightened a few of the pins. Anyway, we all, several of us, went over to his house at lunch to see this amazing Amiga. And he took it out of his pocket, and a few of the pins were really, really mangled. He must have spent, I don't know, 10 minutes trying to straighten the pins up on it. And took the top off his Amiga, plugged it back in, and it works. And he booted this game. And a couple of others, and Dragon Ninja was another one. He had a couple of different games, and I was like amazed at how arcade-like. If you played the arcade version of this, straight away you're like, wow, it's pretty much arcade perfect. I mean, it probably isn't. There is a limitation on, performance on the Amiga. It's perhaps not quite as fast as the arcade, and the sound is marginally different. But you know what? It's a blooming good port. It's right up there, in my mind, with a Mega Drive version. I really like it. The SD version's pretty good as well. So you've been bobbled to death on my channel. I'm always showing that game, and Rainbow Islands. But this is the third game, hang on, that I'm failing at miserably here. Yeah, I mean, look how colourful it is and stuff. It's such a great system, the Amiga, for so many reasons, not just gaming. Productivity and stuff, there's so much you can do with it. Well, I say there's so much you can do with it. There is with an 060 these days, not so much really productivity wise, but yeah, you can play some awesome games on the Amiga. I've got to stop playing this, it's sucking the time out of my day. And I figure, why not see Dragon Ninja actually? It's not a great game from what I remember, but yeah, it just brings back a lot of memories. I think this would have been the first time hang on, if I can start it. This would have been the first time I would have played this or tried this since going to Andy's house. I don't even think I had this on my own Amiga. If I remember rightly, it was a little bit slow, and I think it's one of these. It's an ST port. Could be wrong. Yeah, I think you've got to watch this intro. I think there was something when it popped up on WH Load so you can skip it actually. F1 one player. Let's try that. The arcade game was pretty good. Oh, it's not too bad actually. Well, it's a wee bit slow. Oh, yeah. That's the problem with having one button. Pressed fire, thinking I'd be able to crouch and punch, and you can't. Oh, you can sort of use the direction, sort of down and then go right, rather than press fire. So yeah, it takes you a while to get used to. How do you jump up? And of course, if you hold down fire, you do a sort of power punch. It's a shame it's not got music, isn't it? This is the thing it lacks, and look, it's just a wee bit of a slideshow here. And I'm sure that's something to do with it being a lazy port perhaps of the ST one. There we go. Repaired, recapped 2023. And stick a red dot just for the capacitors, and it's obvious because they've all got a red dot on top. So we're all done. Folded paper with deoxit, clean those, and then it's going to go back to Conrad. Obviously I need to get this into some sort of box. You know, you saw the box it came in. It's probably going to go back in the same box but packaged a different way. I may get some, like, I don't know, forms, some cardboard pieces that I stick on the board, you know, like little spherical bits to stand it off the other piece of card that then has the other board above, and obviously there'll be an ESD bags, and I'll try and get a layer of bubble wrap around the whole thing, so hopefully things will not get smashed off. That's the intention. So I'll perhaps show you some of that actually as I go along, because if you package a board sent to the other side of the world and you want it as packaged as tightly as possible the way it came to me, you have to start to get creative with your packaging, really. But I would definitely get a heatsink onto that Agnes, because yeah, they're really, really rare. When that dies, you're probably going to be knackered. You can see the contamination there that's just come off the end of those, so that is a wee bit dirty. Try and angle slightly different angles, and then you'll get a slightly different pressure pattern, but not too far that you damage the connector. So finally just retinned one or two of the pins there, then it's straightening a bit on both sides, all tinned up where they were fuzzy. So yeah, on the inside as well, and it's been cleaned and tested, works fine. So we'll get that back in, but it did strike me that I've got my adapter here. I think what I'm going to do is I've got something here. I forget what this came from. Oop, a bit of solder fell off there. I think this was from a floating Neo Geo ROM mod from Beeps years and years and years back. This board had a load of wires, and it was just like, how would a ROM socket float? And I thought, oh, I'll take that 40-pin dip socket off at some point. I think I'm going to reclaim this, and I'm going to modify, you know, have another socket, yeah, and produce Conrad one of these. I'll do a separate video on it perhaps. And testing our contraption, it works fine. It's always handy to have one of these little adapters, you know, ready-made and to hand, just in case you come across one of these old revision boards. So checking some of those old capacitors here. Yeah, open circuit low capacitance. This is one of the ones that leaked, I think. So that's no surprise. But if we just continue. Yeah, 47, that's good. I suspect they're all going to be alright apart from the first one we just measured and the other one that I think leaked. Well, I know leaked because the underneath of it was all rushing out. That's another 22, that's alright. Yeah, that one's not good. So that one's turned into a resistor. It's a 22, this one, I think. I'll just check it. Yeah, open circuit, low capacitance, and you saw it showed 6 ohm the first time. So yeah, that one's not good. That's a 47 actually. So yeah, 3 that were bad, 2 leaked as I took them off. Yeah, and I did obviously, you know, put a bit of pressure on the thing as I was pulling it out, and that's when it leaked. And any cap will do that. And you start pulling the legs out of it, it leaks. So I actually think one of them was maybe an issue. All the others are okay, so anyway, I'll put those in the Armageddon bag because I can't send that air mail with the battery in, and that was the 2.7 volt battery. The real-time clock is holding time of day, by the way. So looking around the board on the inside, you can see the fixed wire there for the clock signal, and of course my 2 bodgy resistor arrays there. So yeah, we've got 2 different size resistor arrays, neither of them ideal, which is why I've got 3 additional resistors. But you know what? It's fine. And what have we got up here? I forgot which one this is for now. Oh, that's the clock, isn't it? Yeah. That's a 33 ohm resistor, just helping avoid reflection on the clock that's coming across here. A Schmidt might be better there, but you know what? Out of all my testing, that was rock solid stable. So yeah. And if you look around the board here now, most of the dust and dirt has gone off this. It looks in excellent condition. You've got the original print and stuff there. Yeah, Commodore Amiga 2000, assembly number 380705-01, Rev 4. It's interesting, isn't it? This is a Rev 4. It's a bit different to my Rev 4. I think my Rev 4 is a Rev 4.2 or something, isn't it? Or a 4.4 maybe, I honestly don't know. But yeah, so huge pink EXD bag here. So I forget what type this is. There's different types, isn't there? There's types that, I don't know, they vary. This is a pink one. I always worry with plastic like this plastic's probably now creating ESD as we move the board around inside there. Let's put it back on the bench. As much of the air out of this as possible. It's one of these ones with a double seal though, look, or is it? Yeah, and we'll get the air out as best we can and seal it. The way to do that is to get, hang on, the seal, if you can get the seal, almost closed, like with a little gap in the middle, like that, and just sort of press a little bit and squeeze together. There we go, most of the air's out of that. And I somehow now need to fit it into this. This is what it came in, which is quite insane to me, really. In retrospect, it's literally barely big enough for the board. It's no wonder it got crushed, isn't it? Yeah, it's no wonder it got crushed. It's just like there's no support at all. Yeah, it's like the more I think about this, the more I think what the best approach with this is. Wrap this in a thin layer of bubble wrap, then a bigger layer of bubble wrap, yeah? Stick the other boards, sandwich them together like that, so they're both in 2 layers of bubble wrap with a large bubble wrap around the outside, so it might stand out a bit bigger. It's not going to be as small as the package was originally. And then cut this card here, yeah? Or try and fit it in. It's not going to fit in, is it? Cut this card at the edge, yeah, so that this fits over most of the package. Use the bit we've got here for this extra side, yeah, and then just tape it all up, because then it's going to be pretty well protected internally with the bubble wrap. Yeah, you can see what I mean here. So we've got 3 layers of the small bubble wrap there, but we're going to put a bigger bubble wrap, so you can see, you can still feel like the features like the ROM, the video slots here. So anyway, let's just flip that upside down. I'm going to stick the 1200 on the underside here with its components facing up. Same way it came to me actually, with 2 flat sides facing each other. That's perhaps the best way, but then you're at risk of the things on the outside getting squished off. Right, you can sort of see what I mean. So this is the 1200. It's really well packaged that. Now I've got to try and find the top side nail, which is always a bit of fun. And there's a gap here, look. Yeah. So this bottom side is going to go with this bottom side here. So those two I would feel really comfortable sending in that way, although I'm not sure about the length here. Right, I think at this point actually I'm going to aim to get it like that, yeah? So what I'm going to do actually is pad out this with this stuff, because this is really good at assisting with impacts and things. It's like it's better than bubble wrap in some ways when it's padded out a certain way. And there we go. So I stuck another layer of bubble wrap around the cardboard. I just really didn't feel comfortable with the way it was. And you can see I've just taped it up because it was bubble wrap. So does that look like a drugs package? I think customers are going to stop that. They're going to be like, this is a bit suspicious, lads. It's got bubble wrap, then it's got different bubble wrap, then it's got cardboard, then it's got more bubble wrap, and it's got a ton of tape on it. This must be a drug package or something. That's what we're going to think, isn't it? It's pretty sturdy and it's pretty padded. You could literally play football with that for an hour, I reckon. It'd probably survive. So yeah, but it's big, and that packaging adds a little bit of weight, not a massive amount because it's quite light, but nevertheless That's going to be expensive, I think. Ooh, I could sleep on that. It's like a pillow. Yeah. Anyway, I'm comfortable. Yeah, so I do hope you found that interesting. Please like, share, subscribe. If you'd like to support the channel, please see the Coffee and Patreon links down below. I'll catch you in the next video.